Hello students, a very good evening to all of you. I hope you all are doing good. So today I am going to explain about chemical reactions and equations. This is NCERT class 10th, which is useful for class 10th and all competitive exams. So please subscribe to my Easy Science YouTube channel and click the bell icon so that you will get all the updates from my channel. So let's start our lesson today, that is chemical reactions and equations. Right. So in lower classes you already studied about physical changes and chemical changes. Right. You already know about physical and chemical changes. The changes which are temporary are known as physical changes, and the changes which are permanent are known as chemical changes. So we already know that chemical changes, like in a chemical change, a new substance is formed, and in physical change, no new substance is formed. So this all you learn in your lower sections. So let's discuss in detail about chemical reactions in this class. So I have given here some examples. Just think about these examples which generally occur in our daily life. Like it's the first example which I have given is milk is left at room temperature during summers. You know, during summer season, temperatures are very high, and if you left the milk at room temperature, they got spoiled, right? And an iron tawa or pan or nail that was left exposed to humid atmosphere, you observe that a red color coating will be appeared on the nail, that we called it as rusting. So grapes left over, like kept at room temperature, they got fermented. So fermented means like they got spoiled. And food is cooked initially, like before cooking it is a raw food, and after cooking which can be eatable, and food get digested in our body. We respire, take in oxygen, and you already know in ninth class about cellular respiration, where oxygen is utilized in breakdown of glucose to produce energy. That is, we respire, right? So what do you mean by all these examples? In all these examples, what we identified is the nature and the identity of the initial substance have somewhat changed. Like milk left over at the room temperature got spoiled. Initially milk is very good, and after that it got spoiled. Grapes got spoiled. Food is cooked. So before after, if we observe, there are lot of changes occur and a new substance also formed. Right. So let's have some examples. Like here I have given that magnesium ribbon burns in oxygen, reaction between lead nitrate and potassium iodide, and reaction between hydrochloric acid and zinc granules. So let's discuss about these examples, right? Magnesium reacts with oxygen to give rise to magnesium oxide. Here lead nitrate, that is PbNO3 twice, reacts with potassium iodide, gives rise to potassium nitrate, and lead iodide is formed. Lead iodide is formed. And the last reaction is hydrochloric acid reacts with zinc to give rise to zinc chloride plus hydrogen gas is liberated in this reaction. So in all the reactions what we observed is like magnesium reacts with oxygen which give rise to magnesium hydroxide. Right. So magnesium is different and oxygen is different even after the substance which formed, that is magnesium hydroxide. It's totally different when compared to magnesium and oxygen. And lead nitrate reacts with potassium iodide to give rise to potassium nitrate and lead iodide. Here lead iodide is a yellow color substance and it's a precipitate. Like in general, precipitate can be written as PPT, right? So precipitate means what? So an insoluble substance formed during a chemical reaction is known as a precipitate. So precipitate will be settled in the bottom of the test tube. So lead nitrate reacts with potassium iodide, gives rise to potassium nitrate and lead iodide, where initially the solution, like the mixture of lead nitrate and potassium iodide, is colorless, but after the reaction the test tube turns into yellow color, and hydrochloric acid reacts with zinc to give rise to zinc chloride and hydrogen gas is liberated. So in these three reactions, what examples I have given, we observed is there is change in the state. Like for example, if you consider this hydrochloric acid reacts with zinc to give rise to zinc chloride and hydrogen gas. Here hydrochloric acid is aqueous and the zinc granules are solid, which give rise to zinc chloride aqueous and hydrogen is a gas. So always gas is represented by an upward arrow mark, right? So what happens is there is change in the state, and in this reaction, which is a colorless solution, turns into yellow color, right? That means there is change in the color, and in this reaction a gas is liberated. So evolution of gas. In some reactions change in temperature also takes place, right? So as we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. In our daily life only, we can able to observe a different types of reactions which are taking place around us. So this is the diagrammatic representation where the magnesium ribbon was burned. See, can you observe that the magnesium ribbon was burned? It was producing a white color, right? And I said it's a yellow color precipitate is formed. That lead nitrate is yellow in color. Initially the solution is colorless. Later it was forming an yellow color substance, and here zinc granules are solid, right? It's solid, gives rise to bubbles, right, which is called hydrogen gas. So in a chemical reaction, what we observed is, this is a chemical reaction, and what we observed is there is change in the state, there is change in the color, right, and there is change in the state, change in the color, and evolution of gas takes place, and change in temperature also takes place. So all these will take place in a chemical reaction, right? So let's discuss in detail. Now, magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. Like that only we have written, Noma, right? Magnesium reacts with oxygen to give rise to magnesium oxide. So here I wrote this in the form of a sentence. When a magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. This I have written in the form of a sentence, and as you observe that this is quite long, right? So we can write it in a short form, that we called it as word equation. This is called a sentence, and this is called a word equation, that is magnesium reacts with oxygen to give rise to magnesium oxide, right? So this is called a word equation. Like chemical reactions can be written in the form of word equations, and if you observe in this word reaction, what I have done is, what I have written is magnesium plus oxygen, and I have given an arrow mark where I have written magnesium oxide. So what all these explains to us is the substances which are undergoing, like two of the substances I have written on the left hand side, and one of the substance I have written on the right hand side. So this is RHS and this is LHS, and middle I have given an arrow mark. So what does all this indicates? See, the substances which are present in the left hand side are known as reactants, and the substance which is present in the right hand side is known as a product. So the substances which are undergoing chemical change. See, in this reaction, magnesium and oxygen are undergoing a chemical change and get converted into magnesium oxide. The substances which are undergoing chemical change are known as reactants, and after the reaction, chemical reaction, a new substance is formed which we called it as a product. Right. So always reactants must be written on the left hand side and products must be written on the right hand side. In middle, there is an arrow mark which shows the direction of the reaction. That is, magnesium and oxygen reacting with each other to give rise to magnesium oxide. Gives rise to. So that arrow mark can be spelled it as gives rise to. Right. So we have, like in the word equation, we observe that there are reactants and products. Always reactants must be written on the left hand side and products must be written on the right hand side. And if one or more than one reactant, see, more than one reactant is there, that can be shown in the form of plus sign. Even in the product side also, if you have more than one reactant, that can be shown by adding a plus mark, right? So this is known as about the word equation, and this is also quite long. So there is another way of writing a chemical reaction, that is, the reaction has to be expressed with the help of the symbols, right? So a word equation shows the change of the reactants. I already said reactants and products through an arrow mark placed between them. So reactants should be written on the left hand side. So I am underlining that reactants should be on the left hand side, and if more than one reactant is there, that should be shown with the help of a plus sign. And similarly, the products should be on the right hand side. Even more than one product is there, that can be shown with the help of plus sign. So the arrowhead point towards, always it should be point towards the products. That is, the head of the arrow mark is towards the product. That is, it was showing the direction of the reaction. These substances are reacting and going to produce this product, right? So chemical equations can be more concise and useful if we use chemical formula instead of words. There I have written the word equation, and it will be more useful if you express the reaction with the help of symbols. So chemical equation. So what do you mean by a chemical equation? If a chemical reaction was expressed in terms of symbols. Did you got my point, children? A chemical equation. What do you mean by a chemical equation? If the chemical reaction was expressed with the help of symbols, then that is termed as chemical equation. Right. If you recall the formula of magnesium oxygen and magnesium oxide, like last year, 9th class, you have studied how to write the chemical formula of a substance by using crisscross method. And if you remember that, you can write the formula of the symbols of magnesium. Actually, we have to, the correct word to say is the symbols. It's not formula, it's a symbol. Magnesium, we don't have the formula, it's just a symbol. For atoms, we have symbols. For molecules, we have formulas. So magnesium oxygen symbol and magnesium oxide formula, if you remember, that will be like this. Magnesium reacts with oxygen to give rise to magnesium oxide. So this is called a chemical equation. This is called a chemical equation. So what do you mean by a chemical equation? chemical equation is the chemical reaction that was expressed with the help of symbols is termed as chemical equation. Right. Now let's discuss what is the use of writing the chemical reaction with the help of symbols. Is there any use? Right. So we'll discuss that one. Okay. So we have seen the chemical reaction written in the form of a sentence, word equation, and we have seen this chemical equation. It's just why we are writing the chemical reaction in the form of equation. The answer is just to save the time. That's it. Because the sentence, if the chemical reaction was written in the form of a sentence, it's too lengthy and it's a time taking process. Even the word equation also. But it's very like magnesium, Magnesium. You have to write full word equation means. Instead of that, it is very easy to write the chemical reaction with the help of the symbols, which saves our time. So that's why we'll write all the chemical reactions in the form of symbols, which we called it as chemical equation. Right. And next one. So one more thing, the most important thing is, like in Dalton's atomic theory, we already come across about law of conservation of atoms. Dalton explained that atoms never be created nor be destroyed. In a chemical reaction, they just rearranged. That means number of atoms which are participating in a chemical reaction must always be equal to the number of atoms in the product side, as atoms never be created nor be destroyed, change from one form to another form. So if we observe the example, that is magnesium plus oxygen gives rise to magnesium oxide. So we have to count the number of atoms in the reactant side and product side. Here magnesium is 1 and oxygen is 2. Here magnesium 1 and oxygen 1. Total 2 atoms are there. But here total 3 atoms are there. So the number of atoms are not equal in reactant side and product side. Such a chemical equation where the number of atoms in the reactant side are not equal to the number of atoms in the product side is termed as an unbalanced equation. It's very important to balance a chemical equation. According to law of conservation of atoms, atoms never be created nor be destroyed. They can be changed from one form to another form. So it's very important to balance the chemical equation. Like how you balance the chemical equation? It's just hit and trial method, right? So here I have given two examples. Zinc plus sulfuric acid gives rise to zinc sulfate and hydrogen. This is a word equation. I'll write it in the form of symbols, like in the form of a chemical equation. So Zn zinc symbol is, and sulfuric acid chemical formula is H2SO4, which gives rise to Zn. This O is bigger because it's a capital letter. Zn SO4 plus hydrogen gas is liberated in this reaction. So this is a balanced equation. Here I wrote balanced chemical equation, because if you observe the reactant side, one zinc is there and here also one zinc is there, right? And here two hydrogens are there and here also two hydrogens are there. One sulfur is there and here also one sulfur. Four oxygens are there and four oxygens are there. So this is a balanced chemical equation where the number of atoms in the reactant side are equal to the product side. Let's discuss about this second example. Iron reacts with water to give rise to iron oxide plus hydrogen. This is a balanced equation? Let's discuss. Right. No, I don't have place here. Here only I will do. See, here only one iron is there. But here three irons are there. Two hydrogens are there. Here also two hydrogens are there. But here oxygens are four. right? 4 oxygens are there, but here only one oxygen is there. So what I will do is, here I will write 4 and here I will write 3 and Fe3, 3 Fe is balanced, 4 oxygens, and see this, like here I am writing 3 Fe plus 4 H2O gives rise to, it's Fe3O4 plus H2, right? This is the equation which I wrote, right? So now iron got balanced because product side we have 3 iron and even reactant side also 3 iron. Even oxygen also balanced, here 4 oxygens are there, here also 4 oxygens are there. But one thing, hydrogen did not got balanced. Now I want to explain you that, see, if the number was written down of the symbol of element like this H2, 2 was written like at the end of the hydrogen down, that we called it as subscript. If the number was written as a subscript, that number belongs to only one atom. Here I wrote 4. If I wrote the number on the side, then it belongs to the all the elements present in the molecule. That means this 4 belongs to both hydrogen and oxygen also, right? So I am writing this bigger oxygen, this is capital. You should not write that as a small letter because that is a rule in nomenclature according to IUPAC. So what is IUPAC? International Union for Pure and Applied Chemistry. We have to write the symbol. The first letter of the symbol should always be a capital letter, right? So here hydrogen did not got balanced, so what I will do is, here how many hydrogens are there? 8, 4 into 2. Like side number subscript should be multiplied. So its 4 twos are 8. 8 hydrogens are there in the reactant side, but product side we have only 2 hydrogens. So what I will do is, I will write 4 here. Then it is 4 twos are 8. Here 8 hydrogens are there. Here also 8. 3 irons, 3 irons. 4 oxygens, 4 oxygens. Now the equation got balanced. So this is just a hit and trial method I have done. Right. In order to balance the equation, you have to go on adding numbers. That's hit and trial method. It's very important to balance a chemical equation because according to law of conservation of atoms, number of atoms participating in a chemical reaction must be always equal to the number of atoms newly formed in the product side. That means new products formed, no, the number of elements should be same, right? So next one. The next topic is writing the physical states of the reactants and products which make the chemical equation more informative. What do you mean by physical state? Physical state means, like matter exists in 3 states, right? It's solid, liquid, gas. That will express the physical states of the reactants and products. If that was expressed in the chemical reaction, that makes the chemical equation more informative. So if it is a gas, that can be expressed with the symbol G, if it is a liquid L, and if it is a solid S, and here I have given AQ. AQ stands for aqueous, which means the substance was dissolved in water. See, the word aqueous is written if the reactant or product has a solution in water. When can you say the solution? Solute plus solvent is known as a solution. So it got dissolved in water, then we use the word aqueous. So example which I have given. See, we have balanced the chemical equation, right? It's same 3Fe, 4H2O, Fe3O4, 4H2. Right. So here they have written the physical states of the compounds. That is iron in solid state, water in gaseous state. That means generally water is liquid, but it was in its gaseous form, that is in vapor state, and iron oxide formed as a solid and hydrogen liberated is a gas. If any reaction gas is liberated, the gas is shown by an upward symbol, arrow mark, upward arrow mark symbol, right? Sometimes the reaction conditions, like for example, if we go to photosynthesis equation, what we'll write for photosynthesis equation? Carbon dioxide reacts with water to give rise to, to give rise to glucose C6H12O6 plus oxygen is liberated plus water is liberated. This is not a balanced equation, remember. So, you know that for photosynthesis, sunlight is necessary and chlorophyll is necessary. So, anything which are necessary for the reaction can be written on the above and below of the arrow mark. Sometimes the reactions, like we have, the next class is that one only, type of reaction. Some reactions need energy to start, right? So some temperature is required. So we'll write at a temperature of 370 kelvins, like that. Some requires some pressure and some requires catalyst. So whatever may be needed can be written on the above or below of the arrow mark. So that is also one of the rule. Next one. So here if you observe, carbon monoxide gives rise to, carbon monoxide reacts with hydrogen to give rise to methyl alcohol, CH3OH. It's methyl alcohol, ma. CH3OH is methyl alcohol. So, carbon monoxide reacts with hydrogen to give rise to methyl alcohol. Let's balance the chemical equation. Find out whether the reaction is a balanced equation or not. So, here I will write, ma. So, CO plus, what is happening? CO plus H2 gives rise to CH3OH. So this is a balanced equation or not. Carbon monoxide is a gas and even hydrogen is a gas. I said always gas should be shown with the help of an upward direction arrow mark, and it is methyl alcohol and it's liquid, and it's liquid, right? So, is the reaction is a balanced reaction or not? Let's discuss. Here in the reactant side and product side, we have carbon, oxygen, hydrogen. Even product side also carbon, oxygen, hydrogen is there. So, carbon is 1, reactants, products, this is, and oxygen is 2, and hydrogens here 2 are there. Sorry ma, oxygen I have calculated that one also. It's 1 only ma. Right. And hydrogens here 2 are there. And here carbon 1, oxygen again 1, but hydrogens are 4. Right. It's 3 plus 1, 4. So here only 2 hydrogens are there. So we have to balance the equation. So I will write 2 here. So 2 2s are 4. Now the equation got balanced and we have written the physical states of the reactants and products. So that makes the chemical equation more informative, right? So let's observe remaining examples, that is hydrogen plus chlorine gives rise to hydrogen chloride. So here I will write ma. So hydrogen, no, it's moving. Hydrogen H2 plus chlorine gives rise to HCl. Right. You know hydrogen is a gas. Even chlorine also a gas. But hydrogen chloride is a liquid. So you have to balance the equation. Here reactant side. So this is not there. Here reactant side and product side, if you observe, hydrogen and chlorine Here two hydrogens and two hydrogens are there. Even product side also we have the same elements like hydrogen and chlorine, but one is there. So this is not a balanced equation. We have to balance the equation. So what I will do is I will write 2 here. Now the equation got balanced and I have written the physical states of the reactants and products also. Generally, nonmetals are in either gaseous form or in solid form, right? Like if you observe carbon, it's in solid form, right? Like chlorine, it's in gaseous form. There is an exceptional case where where the non-metals are present in liquid form, only bromine, right? Next one. Barium chloride reacts with aluminium sulfate. Ma. This is barium chloride and aluminium sulfate. Right. So we'll write the chemical equation. Sorry, ma. Barium chloride reacts with aluminium sulfate. Right. Aluminium sulfate means it is Al2SO4 thrice. Because in crisscross method, did you remember, ma? Aluminium is, it's +3. What is happening? Why it was moving? Al +3 and sulfate is, it's -2. Right. So, charges will be exchanged. That is Al2 and it's SO4 thrice. Right. So I have written the same thing. Ma. Gives rise to. What it gives rise to? It gives rise to barium sulfate. Barium sulfate and aluminium chloride is formed. Ma. So it's AlCl3. Aluminium chloride is formed. Just write the physical states first. After that, we'll balance the chemical equation. So eraser is there. So sorry, ma. Okay. I am erasing this. Oh, okay. Right. So we'll just write the physical states first. It's AlCl3, ma. Okay. So barium chloride, we will take it in aqueous form. So barium chloride is a salt which is in solid form. So we dissolve that salt in water which forms a aqueous solution. Even aluminium sulfate is a salt which is in solid form. We dissolve it in water. So these two also we have this aqueous forms only. Right. But barium sulfate is a precipitate. That means an insoluble substance is formed which settle at the bottom of the test tube. Always precipitate should be shown in the form of a downward direction arrow mark. You know, gas is shown in the form of an upward direction arrow mark and the precipitate is shown in the form of a downward direction arrow mark. Barium sulfate is a precipitate formed in the chemical reaction and here aluminium chloride is formed, ma. Right, it's AlCl3. Right, we have to balance the equation. So let's discuss about the reactants and products here, ma. So what are the reactants? See, they are just barium we have, chlorine we have, aluminium we have, and sulfur we have, oxygen we have. The same here also, product side also, barium. What happened? Why it was removing? Barium, chlorine, it's aluminium, sulfur, oxygen. Okay, so barium in the reactant side, these two are reactants. So barium is 1 and chlorine it's 2, aluminum it's 2, and I said SO4, what I said, it's 3 ma. Aluminum sulfate 3, it's got removed ma. I have written aluminum sulfate 3, right? So aluminum, how many aluminum? See, if I have written brackets and 3, this 3 belongs to only sulfur and oxygen. So it's do not belong to aluminum. So aluminum only 2 are there. So sulfur, 3 sulfurs are there. But for oxygen a subscript is there 4 and here 3. Multiply. 4 3s are 12 oxygens are there. So now just discuss about the product side. How many are there? So again barium we have 1, right? And it's SO4. It's just SO4, that is, and chlorine. Here I wrote my, why it was removing I don't know. Chlorine, 3 chlorines are there. Again it got removed. Chlorine, 3 chlorines are there, and here 1 sulfur is there. 1 sulfur is there, and here oxygens are only just 4 oxygens are there. So what we have to write is, right, because here SO4 thrice is there. So what I will do is, here I will write ma. Again here I will write ma. Here, right. So the reaction is, right, okay, here I will write, no, so it's Ba, like, what is the reaction? It's barium chloride BaCl2 plus we have aluminum sulfate, right? It's Al2 SO4 thrice gives rise to, right, it's BaSO4 barium sulfate plus aluminum chloride ma. It's Al aluminum chloride, right? It's AlCl3 aluminum chloride formula, right? So actually here SO4 thrice is there, but here only 1 is there. So what I will write is, here 3 I will write. So which balance the sulfate, and here 2 aluminiums are there. So I will write here 2, right? So 2 aluminiums I wrote. Now aluminum is balanced and even sulfur and oxygen also got balanced. The only thing is chlorine and barium. Here barium 3 are there. So I will write 3 here. So if I write 3 here, barium also balanced, and chlorine 3 2s are 6. Here also 2 3s are 6. So this is the balanced equation where we'll show the physical state, that is barium chloride, aluminum sulfate, barium sulfate and aluminum chloride. All are in aqueous form, but barium sulfite is a precipitate. Always a precipitate should be shown in the form of a downward direction arrow mark. So this is the balanced chemical equations where I have expressed the physical states of the reactants and products also. Right, and here some more examples are there. Again here we have sodium plus water gives rise to sodium hydroxide plus hydrogen. Okay, so here what I will do is, I'll erase everything here. So we have to balance the equation and we have to show the physical states of the reactants and products also, right? So it's not coming, I don't know why. Erase all ink on slide. Very good, it's removed. Okay, so again I will take a pen and I'll write. So what is the reaction which we have seen? Sodium plus water, right? So here I am writing sodium plus water gives rise to sodium hydroxide plus hydrogen gas is liberated. So we have to write the physical states and we have to balance the chemical equation. So just try to balance the chemical equation first. So this is reactants and this is products. So we have the reactants sodium, hydrogen and oxygen, and here also we have sodium, hydrogen and oxygen. So sodium here 1, hydrogens here 2, oxygen 1, and here sodium 1, hydrogens 3 and oxygen 1. See here hydrogens are 2, here 3. Odd number should not be there. So what I will do is, here already 2 hydrogens are there, so I will write 2 here. So that what happens, hydrogens will become 4. Hydrogens will become 4. It's an even number. So now if I change it, sodium also change it. It's 2 and even oxygen also 2. So what I will do is, here I will write 2. Now sodium got balanced and here 4 hydrogens are there and 2 oxygens are there. So I will write 2 here. Now oxygens 2, hydrogens 4. Now this is a balanced equation. Sodium is a solid and water is a liquid and sodium hydroxide is aqueous and this is a gas. I already said gas should be shown with the help of an upward direction arrow mark. So in this way we have to balance the chemical equations, right? So what we discussed here is, and 2 more examples are there here. So you can try these 2 examples. Barium chloride reacts with sodium sulfate and sodium hydroxide reacts with hydrochloric acid to give sodium chloride and water. So you can try these 2 and you can show, like, keep in comment section also that what are the balanced equations for these 2 sentence equations or word equations, whatever you call. So now just discuss what we have discussed is the chemical reactions. We have discussed about the chemical reactions. Chemical reactions, some substances are reacting and producing new products, that we call it as a chemical reaction. Always a chemical reaction, how can you show, like how can you say that a chemical reaction takes place means, if in a reaction, if there is change in the state, there is change in the color and evolution of gas takes place, right? Evolution of gas takes place and there is change in the temperature. If all these have happened, then we can say that the chemical reaction takes place. And this is the diagrammatic representation. Chemical reactions like should be written in the form of symbol. We called it as a chemical equation. In a chemical equation, we have reactants and products. The substances which are undergoing chemical change are known as reactants and the substances which are newly formed are known as products. Right. In between reactants and products, we have a in between reactants and products we have a arrow mark, right? This arrow mark was showing the direction of the chemical reaction where reactants are reacting with each other and form the products. Always the head of the arrow mark should be towards the product side. And we discussed about balancing the chemical equation and how to express the physical states of the reactants and products, and you can solve the 2 and you can show me, like you can express me in comment section. If you like the video, please like my video and share to your near and dears. Please subscribe to Easy Science YouTube channel and click the bell icon so that you will never miss an update from my channel. So I hope you all like the video. Thank you everyone.